Imagine you're aboard a spacecraft, racing toward the center of our solar system. From a distance, the sun appears serene, a perfect golden sphere, bathing the planets in warm, life-giving light. It feels comforting, familiar, the very reason we exist. But as you draw closer, everything changes. The temperature readings climb rapidly. Radiation alarms scream across the cockpit. Your heat shields begin to glow with an eerie orange light under the invisible assault. Instruments flicker and fail, and in that moment, the horrifying realization hits you. You're not approaching a star, you're approaching a roaring nuclear monster, a seething, violent inferno that could wipe out all life on Earth with a single furious outburst. The sun isn't our kind and gentle parent. It's a cosmic horror disguised in blinding beauty. And by the end of this video, you'll understand why even our most advanced spacecraft can barely survive its wrath, and why this peaceful star will one day become the destroyer of everything we know. Let's begin. Most of us grow up believing the sun is a friendly, reliable presence in the sky, a warm yellow disk that rises every morning and sets every evening, bringing light, warmth, and the possibility of life itself. We see it as stable, predictable, almost benevolent. But that comforting image is nothing more than an illusion created by vast distance. In reality, the sun is an overwhelmingly massive object. Its diameter stretches 1.39 million kilometers, so enormous that you could fit 1.3 million Earths inside it with room to spare. If the sun were hollow, Earth would be a tiny, insignificant speck lost somewhere deep within its volume. Its gravity is the invisible glue that holds the entire solar system in orbit. Without this crushing pull, the planets, asteroids, and comets would fly off into the cold emptiness of interstellar space. Yet the same gravity that protects the system also traps a continuous, cataclysmic thermonuclear explosion at the sun's core. This star has been burning for 4.6 billion years, and every second it releases energy equivalent to billions of hydrogen bombs. That power doesn't feel gentle when you get close. It feels raw, uncontrollable, and deeply alien. The closer we venture, the more we realize the sun is not here to nurture us. It simply exists, burning with indifferent fury. The sun possesses no solid surface whatsoever. What we perceive as its bright edge is actually the photosphere, a turbulent, boiling ocean of superheated plasma at roughly 5,500 degrees Celsius. Plasma is the fourth state of matter, where electrons are ripped away from atoms, creating a chaotic soup of charged particles that twist and churn under powerful magnetic forces. There is no ground to land on, no place to stand, no shelter from the heat. If you tried to descend, the temperature would rise dramatically with every layer you pierced. Deeper inside, conditions become unimaginable. The radiative zone and convective zone swirl with massive currents of plasma, transporting energy outward in vast, violent convection cells larger than entire planets. At the very center lies the core, where temperatures soar to an astonishing 15 million degrees Celsius, and pressures reach billions of times those on Earth's surface. Here, hydrogen atoms are slammed together with such force that they fuse into helium in a non-stop thermonuclear reaction. This is not a calm, steady burn. It is a contained explosion of almost incomprehensible scale, held in delicate balance only by the sun's own crushing gravity. Should that balance ever shift even slightly, the sun could expand, contract, or erupt in ways that would reshape the entire solar system in an instant. We orbit a star that is, at its heart, a bomb that has been detonating for billions of years. Beyond its visible light, the sun unleashes a constant barrage of deadly radiation across the electromagnetic spectrum. Intense ultraviolet rays, powerful X-rays, gamma rays, and streams of high-energy charged particles. On Earth, our thick atmosphere and protective magnetic field act as a fragile shield, absorbing or deflecting most of this onslaught so life can thrive. But remove that shield, as happens in deep space, and the sun's radiation becomes merciless and swift. Astronauts traveling to Mars or working on the lunar surface would receive dangerous doses during even moderate solar activity, leading to increased cancer risk, DNA damage, and acute radiation sickness. Spacecraft sent near the Sun require heavy, specialized shielding. NASA's Parker Solar Probe, for example, carries a revolutionary carbon composite heat shield that must withstand temperatures exceeding 1,400 degrees Celsius, while the delicate instruments behind it remain at room temperature. Even with this protection, the probe can only make brief, high-speed dives before retreating to safer distances. The Sun does not target us with malice. It simply radiates death indiscriminately in all directions, a constant, invisible storm that reminds us how precarious our existence really is. The Sun's magnetic field is incredibly complex and constantly twisting under the influence of its rapid rotation and internal plasma flows. When these magnetic field lines become too tangled and stressed, they snap and reconnect with explosive force, releasing solar flares. In mere minutes, a powerful flare can erupt, blasting out as much energy as millions or even billions of nuclear bombs combined. These events flood the solar system with intense X-rays and ultraviolet radiation that travel at the speed of light, reaching Earth in just 8 minutes. The consequences can be immediate and widespread: radio blackouts, disrupted satellite communications, and errors in GPS systems. During periods of solar maximum, strong flares occur almost daily. Each one serves as a stark warning. The Sun is not a passive light source. It is capable of sudden, unpredictable bursts of pure fury that can reach across hundreds of millions of kilometers in seconds. When the Sun's anger peaks, it doesn't stop at a flare. It unleashes a coronal mass ejection, or CME, a colossal cloud of billions of tons of superheated plasma and entangled magnetic fields hurled into space at speeds of up to several million kilometers per hour. These massive ejections can be wider than the distance between Earth and the Sun itself. If a fast, Earth-directed CME strikes our planet, the results are catastrophic. The plasma slams into Earth's magnetic field, triggering powerful geomagnetic storms. In 1859, the Carrington event caused telegraph wires to spark and burst into flames. Today, the same storm could overload electrical grids, destroy transformers, knock out satellites, and plunge entire continents into darkness for weeks or months. Modern civilization runs on electronics that are frighteningly vulnerable. One bad day on the Sun could set humanity back decades. And the Sun has many such days ahead. The Sun never rests. It constantly exhales a supersonic stream of charged particles known as the solar wind, racing outward at speeds reaching 800 kilometers per second. This wind carves out a vast protective bubble around the solar system called the heliosphere, which shields us from the harshest galactic cosmic rays. Yet inside this bubble, the solar wind acts like a relentless, abrasive storm. It erodes spacecraft surfaces, degrades solar panels, and bombards electronics with high-energy particles. Missions venturing close to the Sun must endure this constant assault while also battling extreme heat. The Parker Solar Probe has flown closer to the Sun than any human-made object in history, plunging through the outer edges of the corona itself. Its survival depends on precise timing, robust engineering, and more than a little luck. The solar wind is not a gentle breeze. It is the Sun's breath of fire, shaping and threatening everything in its path. One of the Sun's greatest mysteries lies in its outermost atmosphere, the corona. While the visible surface, photosphere, simmers at about 5,500 degrees Celsius, the corona, the faint, ghostly halo we see during total solar eclipses, reaches temperatures of 1 to 2 million degrees Celsius or more. This defies basic thermodynamics. How can the outer layers be dramatically hotter than the layers below? Scientists suspect magnetic waves, nanoflares, or complex plasma turbulence are responsible, but the exact mechanism remains elusive even after decades of study. The corona is a realm of looping magnetic arches, sudden explosions, and the birthplace of the solar wind. It is beautiful from afar, Yet up close it reveals the Sun as something profoundly alien, a star whose outer behavior still breaks our understanding of physics. During eclipses, that delicate halo serves as both a breathtaking sight and a chilling reminder that the Sun hides secrets we have yet to unravel. In roughly 5 billion years, the Sun will exhaust the hydrogen fuel in its core. When that happens, it will swell into a red giant, expanding outward hundreds of times its current size. Mercury and Venus will almost certainly be engulfed and vaporized. Earth may suffer the same fate, or at best have its oceans boiled away and atmosphere stripped as the Sun's outer layers brush against our orbit. The once life-giving star will become a swollen, unstable monster, pulsing with increasing violence before eventually shedding its outer layers and collapsing into a dense white dwarf. The solar system as we know it will cease to exist. Even now, in its so-called stable middle age, the Sun gives us glimpses of its future temper. Every flare, every coronal mass ejection, every surge in solar activity is a small preview of the violence to come. It has burned steadily for 4.6 billion years and will continue long after humanity has vanished. The Sun never promised us eternity. It simply burns, and one day, that burning will consume everything it once nurtured. The next time you step outside on a bright, sunny day and feel that warm light on your skin, pause for a moment. You are not standing under a peaceful star. You are standing in the glow of a nuclear furnace powerful enough to sterilize planets. A seething monster whose gentle warmth conceals unimaginable violence and inevitable destruction. The solar system is far more dangerous and unforgiving than it appears from afar, and our own Sun is the greatest proof of all. If this journey into the heart of cosmic horror resonated with you, consider subscribing for more. Stay curious, stay cautious, and never forget how small and fragile we truly are beneath the gaze of the Sun.